Let's think about smartphones, social media, or artificial intelligence. All these innovations that drastically change our everyday life have for sure something in common. We didn't know we needed them in the first place. Other than the internet that connects us all over the world, a crucial thing that allowed very important steps for all this invention is the implementation of microelectronics. We're basically carrying a computer in our pockets thanks to these devices. Where else can this technology bring innovation in fields that we might not be aware of? Well, there are certain matters that need to be addressed, such as improvement of air quality analysis and detection of pollutants, enhanced prevention in the workplace, and why not, the likelihood of living on Mars. Well, how can we do that using microelectronics and microsystems? A way to address all these matters is to improve the analysis of complex gas mixtures using gas chromatography. Gas chromatography is an analytical technique that allows the characterization of complex gas mixtures by separating and detecting their components. Nowadays, this analysis mainly relies on cumbersome, bulky laboratory equipment and time-consuming processes. For most applications, it is kind of difficult to imagine it somewhere else in a laboratory. But ideally, using MEMS technology, it is possible to achieve miniaturization of all their components, making these instruments portable. And as a result, their area of application can be expanded to where it was unimaginable before. MEMS is just a word comprising all the devices with at least one dimension between 1 and 100 micrometers, so slightly less than an average human hair. The scope of my project is to achieve miniaturization of the main core component of this technique, which is the analytical column, the portion of the instruments where the separation of the samples takes place. Basically, along the path of the column, the different analytes undergo separation according to their intrinsic characteristics. Very few research groups are still working on this matter, and the majority of solutions were unsuccessful in providing a product efficient enough to reach the market. Having a miniaturized, completely miniaturized and portable instrument would allow us to better monitor the air quality all over the city in real time. We will be able to detect whether there was a leakage of a dangerous chemical in the workplace, or we could use it in space to help astronauts analyze the atmospheric composition of foreign planets. The miniaturization and portability of microsystem and microelectronics have revolutionized our everyday life in unpredictable ways. It will be no different for the world of gas analysis. Thank you.